questions 11 through 12 on the 2006 Grade 8 AMC 8. How many two-digit numbers have digits whose sum is a perfect square? So we've got a two-digit number, and it's obviously got two digits. And when you add those two digits, a plus b, the result is a number that is a perfect square. So the first thing we have to do is look at what are perfect squares. So for example, 1 is a perfect square, 4, 9, 16, 25, and so on, correct? So let's work with these one at a time and see what we get. So first let's start with the 1, this guy right here. If a plus b is equal to 1, what will be our possible choices for a and b? Well, we could have 0 and 1. We could have, say, 1 and 0. And I think that's it. I think that's the only type of possibilities. And therefore, what would be our actual number? Well, it would be either 10 or it would be 1, but it's a two-digit number, so it can't be 1. So 10 is the only way we can create this. All right, let's go to the next one. 4, our next perfect square. If a plus b equals 4, what can be the possibilities for a and b? Well, it could be 0 and 4. It could be 4 and 0. 1 and 3, or 3 and 1, or 2 and 2. And I think that's it. So what will be our actual two-digit number? Let's see, we got 0, 4, that won't work because that's 4, and 4 is not a two-digit number, but 40 will work, 4 and 0. 13, 31, and 22. I think those are the only ones. Yeah. Okay, let's go to the next perfect square, 9. If 9 is a plus b, what are our choices? We got 0, 9, 9, 0, 1, 8, 8, 1, 2, 7, 7, 2, of course, 3, 6, 6, 3, and I think 4, 5 would be the other one. All right, let's now figure out our two-digit number for these possibilities. That would give us 90, 18, 81, 27, 72, 36, 63, 45, and 54. Correct? So far, so good. Now let's go to the next perfect square, which is 16. For 16, we have to get a plus b equal to 16. So the only way to do that is 9 and 7, 7 and 9, or 8 and 8. And that's it. After that, there's no way you can get two single-digit numbers to add up to 16. And these would give you 97, 79, and 88. And then the next one, 25, there's no way to get 25 with a plus b. You can't add two numbers to get 25, two single-digit numbers. So these are the only possible numbers. So let's add them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So number 11, the answer is 17, and therefore that would be C. Antoinette gets 70% on a 10-problem test, 80% on a 20-problem test, and 90% on a 30-problem test. If the three tests are combined into one 60-problem test, which percent is closest to her overall score? So 70% on a 10-problem test would give you 7 out of 10. And then the 80% on a 20 problem test is 16 out of 20. And 90% on a 30 problem test is 27 out of 30. So all of these are combined into a 60 problem test. So if you add up all the ones she got correct, it's 7 plus 16 plus 27, and that looks like 50. So 50 out of the 60 problems she got correct. And as a percentage, that is about 83%. So number 12, the answer is D. Cassie leaves Escanaba at 8:30 a.m. heading for Marquette on her bike. I think these two places are in Michigan. I think. She bikes at a uniform rate of 12 miles per hour. Brian leaves Marquette at 9 a.m. heading for Escanaba on his bike. He bikes at a uniform rate of 16 miles per hour. They both bike on the same 62-mile route between Escanaba and Marquette. At what time in the morning do they meet? All right. So they're both heading, I guess, towards each other, right? Because one starts in Escanaba and the other one starts in Marquette. So here's Escanaba and here's Marquette. And 8:30 a.m. Cassie leaves and she starts going this way. And Brian actually starts at 9 a.m. So he starts 30 minutes later. So first we have to figure out from 8:30 a.m. to 9 a.m. how far did Cassie go? So that's 30 minutes, which is a half an hour. And she's traveling at 12 miles per hour. So 12 miles per hour times half an hour is equal to 6 miles. So she gets 6 miles into this journey. So approximately here, let's just say. So that's 6 miles. And that is exactly 9 a.m. is when she gets there. And that is when Brian starts his journey. Okay, he starts at 9 a.m. Now, they both are traveling towards each other, right? Because Cassie is going this way and Brian's going that way. And eventually, I don't know where, but eventually they're going to meet somewhere. Let's just say they meet here. I don't know where they're going to meet. But if they do meet there, I'm going to label this distance x, and this distance will be therefore all the way from there to a starting point 62, because 62 is the total route between the two cities, minus this 6 minus this x. So minus 6 minus x, okay, which is 56 minus x. So that's the setup of the question. Now, what's important to remember is eventually when they get to this point, they meet. So I'll just write Cassie, comma, Brian to denote the fact that they are going to meet there. That's where they're going to end up in terms of when they first cross paths, I guess. Now, that basically means that the time it takes Cassie to go from here to here is the same amount of time that it takes Brian to go from his starting point to that point. So the times are equal. So the time that it takes Cassie to travel that distance is the same amount of time it takes Brian. Okay? That's the start of this equation. Now, you all remember the speed formula. Speed is equal to distance over time. And therefore, time is equal to distance over speed. So that means for Cassie, her distance over her speed is equal to, for Brian, it will be his distance over his speed. Okay? So there we go. This is the equation that will help us solve this problem. So for Cassie's distance, she's traveling from here to here, and that is x. We don't know, so I just denoted it as x. But we know her speed. Her speed is 12 miles per hour. For Brian, his distance from here to here, we got 56 minus x. And his speed is 16 miles per hour. So this is the equation we got to solve. Cross multiply and you get 16x is equal to 12 times 56, which is 672 minus 12x. And therefore this becomes 28x is equal to 672. And therefore x is equal to 24. So this x is 24. And this 56 minus x, I don't know if that's important, but it's 56 minus 24, which is 32. Okay, now what is the question asking? The question is asking, at what time do they meet? Okay, well, you can do this either way. You can use either Cassie's information or Brian's information. I'll just use, well, it doesn't really matter. I can use Brian's information or Cassie's, whichever one you feel is easier. If I use Cassie's information, it's 12 miles, her speed in 1 hour. And we are told that she's going 24, but her total from there to there was 6 plus 24. So that's 30 miles. Okay? And we have to figure out her time that it takes her to go from here to here. Okay, so I'll just put time. It doesn't really matter. So I got 12t is equal to 30. So that means t is equal to 30 over 12. And that's what, 2.5? Yeah, 2.5. So it takes Cassie 2.5 hours to go from her starting point to the point where she meets Brian. She started at, remember, she starts at 8:30, and then 2.5 hours later is where she ends up here. So 8:30 plus 2.5 hours would be 9:30, 10:30, 11 a.m. is when she ends up right here, the meeting spot with Brian. So number 13, 11 a.m. is choice D. Problems 14, 15, and 16 involve Mrs. Reed's English assignment, a novel assignment. The students in Mrs. Reed's English class are reading the same 760-page novel. 3 friends, Alice, Bob, and Chandra, are in the class. Alice reads a page in 20 seconds, Bob reads a page in 45 seconds, and Chandra reads a page in 30 seconds. Number 14, if Bob and Chandra both read the whole book, Bob will spend how many more seconds reading than Chandra? So it's a 760-page book, and we'll just denote them as A, B, and C, first letters of their names, make it easy for us. And Alice is 20 seconds per page. Bob is 45 seconds per page. And Chandra is 30 seconds per page. I'm making her read faster. There we go. So they are both going to read the whole book. All right. So Bob will be 45 seconds per page times 760 pages. And that is 34,200 seconds. And then Chandra looks like it will be very similar in terms of how to calculate it. 30 seconds per page times 760 pages. And that is 22,800 seconds. So how many more seconds did Bob take than Chandra? Well, I guess you just subtract those two. And if you do, you get 11400. So number 14, the answer is B. . Chandra and Bob, who each have a copy of the book, decide that they can save time by team reading in the novel. In this scheme, Chandra will read from page 1 to a certain page, and Bob will read from the next page through page 760, finishing the book. When they are through, they will tell each other about the part they read. What is the last page that Chandra should read so that she and Bob spend the same amount of time reading the novel? Okay, so I don't know the answer, so I'll call the number of pages that Chandra reads X. She reads X number of pages. So her time is 30 seconds per page times X. And that has to equal, because they both have to have the same amount of time, Bob's story, which is, how much was he? It was 45 seconds per page, right? 45 seconds per page. And for him, he's reading the rest of the book, so it's 760 minus X. Okay? So those two have to equal. So that means basically that 30X is equal to 45 times 760 minus X. So 30X is equal to 45 times 760 is 34,200 minus 45X. And if you bring this over, you get 75X is equal to 34,200. And therefore X is equal to 456. So X represented how many pages that Chandra read. And that's what they're asking. What is the last page that Chandra should read? So that's 456. So number 15, the answer is C. Before Chandra and Bob start reading, Alice says she would like to team read with them. If they divide the book into 3 sections so that each reads for the same length of time, how many seconds will each have to read? So in this case, the 3 are going to read the same amount of time, same length of time. So that means if I let's see here, Alice, Bob, and Chandra, right? And let me see if I recall their time. It was 20 seconds per page for Alice. Bob was 45 seconds per page, and Chandra was 30 seconds per page, correct? Yeah. So if they're all reading the same amount, let's say Alice reads X number of pages, Bob reads Y number of pages, and therefore Chandra would be reading the remainder of the book, which is 760 minus X minus Y. So this in an equation would be 20x is equal to 45y is equal to 30 times 760 minus x minus y. Correct? Okay. So here we go. We got to solve this. So this is essentially 2 variables this time, but I've got enough equations, I think, to solve for this. So the first equation, I can just use these 2 guys, and that would give me 20x is equal to 45y. So that means x is equal to 45y over 20, and therefore x is equal to 2.25y. And I think that should be good enough. I can use either of these guys here. I'll just say this one and this one. Either way, it doesn't matter. 20x is equal to 30 times 760 minus x minus y. Okay? So 20x is equal to 30, 760 minus x. And then y, since I've got a lone y in here, I'll just put it in terms of x. Y is actually 20 divided by 45, x like that. And that is 0.444x, like this. All right, so let's multiply this all out. 30 times 760 is going to give you 22,800, like that. And this is minus 1.44 times 30. So that's going to be 43.333, repeat x. And then put that on one side. So we're going to get 63.333 x, and then divide through, and that gives me x is equal to 360. Okay, and now to figure out how many seconds did each read, you can just use this guy. That will give you Alice's time, and Alice's time is equal to the other two times. So that's 20 times 360, and that is equal to 7,200. So the answer here to number 16 is E. Jeff rotates spinners P, Q, R and adds the resulting numbers. What is the probability that his sum is an odd number? It's a probability question, and like all probability questions, it's going to be a numerator and a denominator that I need to figure out. And in our case, our denominator is the total number of possibilities, and our numerator is specifically the requirement in the question stem. So our denominator will be how many choices do we have for the first one, multiplied by the choices in the second one, and multiplied by the choices in the third one. So here we've got 3 choices for P, we got 4 choices for Q, and we have 6 choices for R. 3 times 4 times 6 is 72. And then now I'm going to concentrate on the numerator. So when he spins this, the 3 numbers have to add up to give an odd number. All right, so P plus Q plus R have to add up to be odd. All right, well, for each of these numbers, P, Q, and R, the number itself is going to be either even or odd, right? So let's just see what are the possibilities here. If they're all even, and even, that's going to be equal to an even number. If they are all odd, like that, then that would be an odd number. And similarly, if we've got even, and odd, plus even, plus odd, that is going to be an odd number. And then the next possibility is even, odd, even. And when you add those up, that's odd. And then the next one is odd, even, even. And that's odd also. And then the last 3 are even, odd, odd, which is even. Odd, even, odd, which is even. And finally, odd, even, which is even. Now we want a sum that is odd, correct? So we only need to concentrate on this, and that scenario. Okay? So let's take this one step at a time. Let's start with this guy. Odd, odd. Okay? So for P, if we want an odd number, there's 2 possible choices. So that'll be 2. Multiply that by odd from Q. But in Q, none of those numbers are odd. Oh, okay. Well, that means that this guy is a dud. There's no way of doing that one. Okay, no problem. Let's go to the next one. Even, odd. Okay? If P is even, there's one way. If Q is even, 4 ways. All 4 of those are even. So 4 there. And then odd for R. And all 6 of those are odd. So that means there's 24 possibilities for this scenario. Okay, let's go to the next one, even, odd, even. So even for P, it looks like one possible way of making that even. Odd for Q, and none of those are odd. So this is a dud. And then lastly, odd, even, even. Odd for P, there's 2 ways. Even for Q, there's 4 ways. And then even for R, none of those are even. So 0 for that. So I guess the only way is even, even, odd, and there's 24 ways of doing that. So the numerator here is 24. So that probability is 24 over 72. In lowest terms, that is 1/3. And that would mean number 17, the answer is B. A cube with 3-inch edges is made using 27 cubes with 1-inch edges. 19 of the smaller cubes are white and 8 are black. If the 8 black cubes are placed at the corners of the larger cube, what fraction of the surface area of the larger cube is white? So the first thing I'd like to do is draw a cube. And we want to divide this cube into 27 small unit cubes. And once we do that, we'll start looking at what's going on with the white cubes and the black cubes. All right, so here we go. Now the black cubes are placed at the corners, right? So these guys here, I'll paint the sides like that. Those are going to be black. These guys right here. Okay? Now, one thing you need to know and notice is that when the corners are black, how many of those faces of the small cubes are black? Well, each corner has 3 faces that are going to be black. The other 3 are going to be hidden inside. So that basically means that you've got 8 corners, and each of those 3 faces will be black. So 24 total black faces. Now, in the total cube, how many small faces do we have? Well, we've got 6 sides of a cube, and on each of those sides you will see I've sectioned it into 9 small unit cube faces. So 6 times 9, which is 54 small faces. Okay, I hope that makes sense there. Now, if 24 of them are black, the remainder, which is 54 minus 24, the remaining 30 are going to be white. Okay, so for example, here's one such white small face. So they want you to figure out what percentage or fraction of this entire surface area is white. Well, the entire surface area is 54 small faces, and we already figured out that 30 of those are going to be white. So that is the fraction. In lowest terms, if you divide top and bottom by 6, you'll get 5 over 9. So number 18, the answer is D. Triangle ABC is isosceles, and AB is equal to BC. Point D is the midpoint of both BC and AE, and CE is 11 units long. Triangle ABD is congruent to triangle ECD. What is the length of BD? Okay, let's label this a little bit. AB is equal to BC, correct? So if I say that AB is 2A, BC will be 2A as well. But they also tell you that D is the midpoint of BC. So that basically means that BD and DC are the same length. So if BD is A, DC is going to be A. All right? And then they also tell you that D is the midpoint of AE. So this length from A to D is going to be the same length as D to E. So if this is B, that is also B. And then they also tell you that CE is 11. And then they let you know that these two triangles are congruent. ABD is congruent to ECD. And if they are congruent, then the ratio of the sides is going to be equal. So, for example, AB over BD is equal to EC over DC. Okay, there's lots of different relationships you can come up with, but this is one. Well, in our diagram, AB is 2A, BD is A, EC is 11, and DC is A. So this basically just simplifies to 2A is equal to 11, and A is equal to, therefore, 5.5. And 5.5 is the length of BD, since BD is A. And therefore, number 19, the answer is D. A singles tournament had 6 players. Each player played every other player only once with no ties. If Helen won 4 games, Ines won 6 games, Janet won 2 games, Kendra won 2 games, and Laura won 2 games, how many games did Monica win? So we've got, let's see, H, I, J, K, L, and M. These are the 6 players. And how many games are we going to have? H will play I, H will play J, H will play K, H will play L, and H will play M. And then I will play J, I will play K, I will play L, and I will play M. Then J will play K, J will play L, and then J will play M. And then we've got, let's see, K will play L, K will play M, and then finally L will play M. And this is, let's see, 5, 4, 3, 2, 1. That's 15. 15 games being played. And since there's no ties, there's 15 wins and 15 losses. And they tell you the number of games that are won are 4 for Helen, 3 for Ines, 2 for Janet, 2 for Kendra, 2 for Laura, and then Monica is how many we have to figure out. Well, the total number of wins is 15. So this column has to add up to 15. So that means 4 plus 3 plus 2 plus 2 plus 2 plus x is equal to 15. So that means I got 7 plus 13 plus x is 15, and therefore x is equal to 2. So Monica won 2 games. So number 20, the answer is C.